So one can check the significance of any variable with the help of these p-values, right? And is that particular variable is significant or not, whether that particular the model which we are considering it is significant or not. Based on this p-value one can conclude. Okay, so first of all, here based on this we have created a model. This is your model. Okay, but we have tested each and every very coefficient, that is your beta naught, beta 1, beta 2, beta 3, right? So which betas are significant, that we have to consider. Okay, so that is called significance model. So we need to write a significance model which is significant. Okay, and we have to see, this is one uh, in your practical they have not given much description, like what will be expected output, and they have just given the syntax and they have to just execute and you'll be get the output, but it has no meaning. It has no meaning because they told you perform MLR. You perform MLR. So when they are saying you perform MLR, that means you need to you need to you need to go through entire theory of that, and you can, based on that, you have to do all calculations. Okay, so this was the first concepts where we have created a model, and then if the overall model is significant, then we go for individual testing. This is also we have studied. If overall model is significant, then we go for individual testing. So here the very important first thing you check for, means here you have created a, means here you have formed the model, right? Here you have formed the model, which is y2 is equal to x21 plus x22 plus x23. We have formed the model. Based on that we get this output. So first of all we need to write down conclusion for this one. This is the first conclusion. So conclusion based on r square. First we need to write a conclusion based on r square. So this is the first one. Okay. So what is your r square value here? R square value is what this r square value says, 71.8% of variability in the dependent. So which is your dependent? So you need to go to back and see which is your dependent variable. So I think dependent variable is a gestation period which is given in the days. So in the, which is your y2 is explained by which is your first one. You need to just go check, go back and check that data. So body weight, brain weight, which is your you can call, if you want you can don't take in units. This is your I think x21 comma body weight, which is x22, and finally we have average litter size. Average Letter size, that is your x23. So 70%, 71.8% of the variability in my gestation period is explained by all remaining independent variables. So whichever remaining independent variable is there, like x21, x22, x23, they are all my independent variable, and they are contributing all this information. How much? 71%. So this is the first conclusion I have to check in my output. After that, after that, therefore, therefore, model is good fit. Therefore, model is good fit. So, how much percent do you think that whether model is good fit or not? How you decide?
More
How you
than
decide?
70%.
How you decide ki whether the model is good fit or not? How you check? See, R square value is just whether model is good fit or not. R square value is just representing how much of the variability is independent variable is explained by independent variable, right? And based on that, we say the model is significant. Even if the even if like even if it is 50% or see in real life situation I may say 50 to 60%, not 50,
Is
I
variable.
did more, I can say 40 to 45%. 40 to 45%, if I'm saying I have created a model, then till the model is still the model is good fit in a real life situation. Okay, because this is the data, something like that. This is all manipulated data, so obvious there has to be a good, I can say, r square value. But in real life situation, if your r square value is like above 45 or 50, then your model is significant, model is good fit. Okay, we can go with the model, always remember. Okay? So model is good fit. So once the model is good fit, once the model is good fit, what you have to do, what you have to do, we can check for f statistics and their p value. So this is for overall p value. This is the overall p value. Okay. So here second task is we are testing for overall significance of model. Significance, significance, overall significance, overall significance. What not? So in overall, what we found here, you can see the p value. The p value is coming this one. Even it is lesser than this one. You can see this is lesser than this one. So one can take this one also, lesser than this one. That you can take this lesser than this. And we are considering with 0.05 always, okay, at 5% level of significance. So what you can conclude, since p value is lesser than, I will not considering less here because then other will get confused. Let consider this is 2 point something. Okay. 10 raised to minus 16. But this quantity will be always lesser than, even if I consider 0.01, 0.001, 0.00001. Okay. So the p value is less than alpha value. We
We
reject
reject that now.
we reject H naught. we reject h naught means what?
There is no significant. There is significant.
There is no significant, there is significant.
Significant.
You are
There,
rejecting h
there is
naught, that
significant.
means there is significant difference among the coefficients. That is we say na, all betas are not equal to 0, right? That is all betas are not equal to 0. So so we found that all betas are not equal to 0. So so which betas are equal to 0? That means we are interested, means there has to be some value. There has to be some values of beta. So one can see this beta is 0.01, this beta is 0. And this beta is, you can say, minus 27, like. So which beta is like 0? Okay, that is our task. See, if I'm saying, that means the overall model is significant, you are saying. This means saying the overall model is significant, and whenever the overall model is significant, we always go for individual testing. So we go for individual testing. Okay, we go for individual testing, and we start testing with beta 1, beta 2, beta 3, and so on. Okay, so I've started with this R square. We found model is good fit, and then we take test for overall testing. Overall testing, we found that it is significant. Overall model is significant. The overall model is significant. That means we can go for individual testing of coefficients. So you have to check for all individual testing. So for all individual testing, we have to check whether this beta beta 21 beta 21 or beta 22 or beta 23 are significant or not. Okay, so here also they have given output for this one. So I may use the notations here. Let's see whether some symbols are there or not. So here we have a beta 1 2. So beta 1 2, we have found that so this is the beta 1 2 0 versus, I can say, h1, which is not h0. Okay. So since I'm testing for h testing, so I have to define the hypothesis. I have to define hypothesis, and the first hypothesis, that means individual testing, that means we need to check for beta 1 2. And what is your p value in that case? P value is 1.79 10 raised to minus 6, means 0.000, and then we have a that particular number. Again, this value is less than 0.05. We reject h naught. That means we reject h naught. That means again your beta 1 is not equal to 0. You are rejecting h naught. You are rejecting h naught. That means that means your regression coefficient beta 1 2 is not equal to 0 means it has some particular value. So you can see this is some value. Okay, so this is not 0. Similarly, you have to check for next one. What is your next one? This is beta 2 2. Beta 2. This is 2 versus this. Again, you have to write the same conclusion here. So the p value is coming 0.6663. Put it here. What we can find here now, this value is larger than 0.05. So we do not reject H. That means if we are not do not rejecting H naught, that means in this scenario your beta 22 value is not significant. Even if you remove that particular variable, it will not significant in our model. So one can remove that variable. Now what is next one? So the next one is, I think, beta 23, and p values again it is something 10 raised to minus 12. So if 10 raised to minus 12, I'll keep it here. The conclusion is going to be same. We have to reject H naught because this value p value is lesser than 0.05. So in this scenario, what we found that the regression coefficient beta 21, beta 12, and beta 23 is significant, whereas beta 22 is not significant. Okay, so one can see I may remove this particular value which is not significant for the model. So this is my overall significance. Overall, this is called significance model, or I will not say overall, I will say significance model. So this is my significance model, and you will be get the so this is the way we have to always write the output for the multiple regression model. So first one, so whenever we get such a output, then how do we write the conclusion? So first we go for the checking R square value. Once the model is good fit, one can go for overall testing. If model is significant, we go for individual testing. And in individual testing, we found that some coefficients are, some variables are not significant. Okay. So if the coefficients are not significant, so I may remove that particular variable. So here beta 22 is not significant. So I may remove the x22, and this model is a properly, which is your, I can say, uh, this has become your significance model. Let me know if we have any query. Uh, somebody have some query. किसके बारे में है जो लिखा है वो समझ में I wanted to send. Okay, okay. Shaili, you were not present last class. Shaili is there.
Yes, sir. I was there.
So this is the question number one. We are discussing for the practical number. I think MLR. MLR का क्वेश्चन नंबर वन का हमने कल लास्ट टाइम हमने ये किया था ना, आर पे एग्जीक्यूट किया था, तो उसका आउटपुट मैंने पेस्ट किया है एंड then this was the output, and now we are trying to conclude the result based on this. We are trying to interpret how we can write the output if we get such a output. Okay, so how we can able to write the interpretation part. uh, on what basis you where we write suffix of beta 1? See, this is, see, the beta 1 2 beta 2 2 beta 3. It is not necessary you write, you go with this always. Okay, you can go with beta 1 x1 x2 x3. You can go with x1 x2 x3, no problem. Why I'm considering here beta 2 1 beta 2, because you can consider here y is equal to x1 x2 x3, because why I'm saying, because we have seen here, if you see our theory part, we have written the model y is equal to x beta plus epsilon, and x will be, it's a matrix, it's a matrix, and in matrix we have all the observations, and those observation is considered to be the in a form of x12 x21 x like that. Okay, so even if you go with
Yes, sir.
why I'm considering, because it is a part of your variable, so some
Yes,
way
sir. But we have only
that,
three beta, beta 1, beta 2, and beta 3. So we can directly write this. Okay.
sorry, I can't hear you anything. Voice is breaking, or I can just increase my, let me wait. Yes, बोलिए, अभी बोलिए, I think I can hear you. I think even if you go with x12 x2 or x3, it's okay. Yeah, we have tried only three betas, because there is only three betas. See, they have in our output, as I mentioned, this is the new practicals which is given by the university, and they have done this all, like, they have just given the output. Even the answer is also not given. Just they have just given the syntax which I have shown you the last class, like this syntax. I will show you that syntax. This syntax. They have just given this syntax, even not written any properly ways, but even it will run on auto, we don't know. But based on that syntax, we have a form everything, and then just they have just given the output. They what actually they what they want from the questions, they have not mentioned. They have execute everything, but we don't want to execute everything. We need to understand the conceptual things, and we have to write it down in that particular form which I have shown you here, right? In this way we have to write it down all the practicals at least. Okay, how did you return for the CS, your SLR? सिंपल लीनियर मॉडल के लिए कैसे लिखा है आपने? Is this way you have written? Because in examination you have to write in this way. In your practical examination you have to write in this way. So if you have not written of doing this practice, be on keeping the practice of such a, means you consider any example and then you try to interpret that particular data in terms of given this is a format. Okay, so this is a format we have to always find. Okay. So any query so far, writing the things, because I think this is all we have discussed in the last class, and based on theory we are doing all, so there could not be much difficulties like doing the things. Yes, anyone? Yes, Aman. Is there any difficulty?
No, sir.
Okay. Dikshita is there or not? Dikshita,
Yes, sir.
you are there.
Yes.
Have you attended last lecture?
No, sir.
Why?
सर लाइट नहीं था घर पे,
अरे
इधर
लाइट
काम
नहीं
चालू था।
लाइट
और
नहीं था तो मोबाइल में चार्जिंग भी नहीं था।
नहीं नहीं वाईफाई पे रहती हूँ ना, इसीलिए।
अरे डेटा भी रखने का बेटा।
हाँ सर, ठीक है, नेक्स्ट टाइम रखती
Okay.
हूँ। हाँ।
Okay. So this is the way you can go with the output interpretation. Let's move ahead. So I'm just sharing the next part of that. See, we have just done 1% of my output अभी तक. Okay. तो मैंने क्या लास्ट टाइम मैंने समरी रन किया था और समरी रन करने के बाद मुझे वो जो आउटपुट मिला था वो मैंने आउटपुट वहाँ पे पेस्ट किया था. So I'll execute once again. Okay. So this is my view data. It will execute. No, I have to import once again. So just look if you have not attended the last lecture. Sorry. So what we did in last class, we have I'll show you question first because this was the questions. This one, first one, we have to carry out MLR based on mammal size XLS data, and these are the variables we have assumed. Okay, and the first one is the name of species which is not required, and remaining are the variable which you have to consider. The first one is your dependent variable, rest are your independent variable. Based on that we are doing all analysis, but you can see here they have just mentioned carry out MLR, nothing mentioned what we want and how we want. Okay, so the way which I am now teaching you, that same exactly you follow in your examination. So let me share the uh, our output. So that means mammal size data we need to import. So we can go to import. Let me use the choose wala options, whether it is working or not. Let me know. Choose dot file. See, once I have written choose dot file, automatically the window will be open, and here from here we need to take the data. So where is the data? You need to select the data from particular path. So I have the mammal size data inside my folder, mammal size. Open it. You can see, one can see here automatically this path is executed. That means you have imported your data successfully. Now just click on view mammal size. Acha, you have to run it. I think this one. You have to read. You have to read that particular file. Okay. So read. I think you have to read that particular data. They are saying read.csv. Acha. Read.xls is there. No.
सर ये तो इंपोर्ट करने के लिए होता है.
हाँ
सर ये इंपोर्ट करने के लिए होता है.
क्या?
सर आपको फाइल लेना है, जैसे चूज डॉट फाइल्स हो गया ना सर, वैसे ही ये भी काम करते हैं.
नहीं, तो आपने फाइल तो ले लिया, लेकिन फाइल को रीड करना. जैसे आपने कोई पैकेज आपने इंस्टॉल किया, पैकेज इंस्टॉल करने के बाद यू हैव टू कॉल ना.
तो सर
तो
लाइब्रेरी से होता है ना शायद.
हाँ
नहीं होता पैकेज. हाँ
हाँ, मतलब आई एम जस्ट सेइंग द एग्जांपल. जैसे कि आपने कोई पैकेज इंस्टॉल तो हो गया, तो लेकिन उसको बुलाने के लिए वी नीड टू राइट अ लाइब्रेरी. वैसे ही जब फाइल आपने जब सिलेक्ट किया ना, तो पर्टिकुलर पार्ट से आपने फाइल ले लिया, लेकिन वो फाइल को रीड करने के लिए आपको कमांड डालना पड़ेगा. ओके, सो आई थिंक read dot table is working. Let me know whether read dot table and particular path you have to paste. Let me see, yeah, because I'm just executing the first time trial on the trial basis. Okay, let's leave it. Let's go to the our uh, usual method. So click on import data set. Go to from Excel. Select that particular file. So browse it. Go to particular path. So that particular ML size. It's retrieving the preview data. So you have to wait for retrieving the data. See, now you can see the data. You can retrieve the data, and once it is done, you need to click on import. So once you click on import, you can able to see the path. See which the command which I was just discussing, read underscore Excel. See, even if you go with this now, read underscore Excel, it will also work, I think. Okay, so you can just try for that. Now you can view this. You can be able to view this. Okay, just let me check with this. Read underscore Excel, and then paste this path. Yeah, it's reading. You can see it's reading. So whenever you want to import any file, so you can go with the choose.file and read underscore Excel you can use. If it is Excel, if it is CSV, then read.csv that we have seen, and then write the path. And automatically you can view the file, and then you can click on view the file. You can able to see the file on the next tab. Okay, that is memo size. This is your memo size data. So this is the actual size where we have a 5 variable, and these variables are dependent and these 3 are independent. And then we have seen how to store the data. The storing part is done. You have to need to just store the, because always writing the gestation period, brain weight means variable name, it's quite difficult. So instead of that, you can store it in the particular variable like x21, x12 like that. See, it is not necessary you write the same thing, but better you can have same data. But don't get confused. You can go with the y. Why I'm not telling you, because maybe some the universities, because it is given by university practicals, okay, university teachers. So who are going to evaluate the things, they must know the, like, whatever things are given by the university, they prefer that one. Okay, so that's why I am not changing much notations, not changing the much notations in that output, because that is the in syntax also. But definitely instead of writing model 1 2, you can go with it. There is no problem. So even I can take this the model 1. You can take the model 1. So model 1 executed. Why to acha? We have to run this all, because, and then model 1 is executed. You can get the summary. Acha, model 1. So you can see when object is not found मतलब क्या था, मैंने इसको execute नहीं किया था इसको, because you have to change, this is the, because x2 I have written here but x2 exist नहीं है, इसलिए object is not found. So whenever situations arises, you may change the model name and then you can. So you can see the summary of that. We are getting same summary, which I have just spoke now, and based on that we have interpreted out. Now the next task is that we need to check all different residual, whether in our model residual is exist or not. Okay, so for that purpose we need to create a plots. One is the residual versus leverage plot, then heteroscedasticity, that is the you can say restricted versus leverage plot, and then we have a normality assumptions, which is your QQ plot. I think this is all we have understand last class. So we can just plot to just, so for doing all these, we need to just run one command, which is plot model. So see, now if you just if you just run this one, कुछ मिलेगा नहीं आपको, तो आपको क्या करना है, कंसोल पे क्लिक करना है. Once you click on console and if you just press enter button, remember once you plot this you need to click on console button, enter it. तो जैसे आप एंटर करोगे ऑटोमेटिक यहाँ पे प्लॉट आ जाएगा, ऑटोमेटिक प्लॉट आ जाएगा. And what this plot explains, that we have seen everything in the last class, right? Residual versus fitted का क्या concepts है, कैसे क्या होता है, okay? Everything we have seen in the last class. Then the first one इधर देखेंगे तो हो जाएगा, residual versus fitted वाला leverage points वाला हो जाएगा. Then next one QQ plot, you can see QQ plot. Then scale location plot, and the last one is residual versus leverage point. Okay, so I will zoom it that if we are able to see the screen. So if you just see the screen, what we have discussed for the residual versus leverage in the last class, you can see the video of that last class who is not present. We have discussed about this point, corner points. So based on these corner points, we need to check the outliers. So you can see at this is my corner point, and out of that this point is outside. That means 72 is the problem. 72 is the outlier which is creating a problem in our data. So we need to remove the 72. Okay, so this is the concept we have seen in the last class. So you may take down that. And so how we remove that? So you can see I have written again mammal size dot 1. Okay, तो मैं क्या कर रहा हूँ, मैं सब डेटा मेरे पूरे डेटा में से जहाँ पे 72 है उसको मैं रिमूव कर रहा हूँ. जहाँ पे 72 है उसको मैं क्या कर रहा हूँ, रिमूव कर रहा हूँ. तो मेरा ओरिजिनल फाइल नेम क्या था, मेमल साइज. तो मेमल साइज में से मेरे को रिमूव करना है, तो रिमूव करने का क्या ऑप्शन है, -C72 कॉमा. ओके, so that particular row it will be deleted, and that everything I am storing in the new variable, which is a new data set, which is mammal size dot 1. so mammal size dot 1 में आ जाएगा सब डेटा, एंड उसके अंदर -72 का जो भी 72 का ऑब्जर्वेशन रहेगा वो रिमूव हो जाएगा. ओके, so I have to just execute this one. एंड इफ यू वांट टू सी अगेन कि 72 वाला है, तो फिर से आप व्यू मेमल साइज डॉट 1 पे आप व्यू करो, तो 72 वाला जो भी डेटा रहेगा उसे रिमूव हो चुका रहेगा. अभी क्या हो गया, मैंने आउटलायर रिमूव कर दिया. आउटलायर रिमूव करने के बाद मुझे फिर से चेक करना है मेरा मॉडल सिग्निफिकेंट आया है कि नहीं आया. Okay, so this is we have to do continuous till the model gets significant. Model get, देखिए मॉडल में हमारे आउटलायर एग्जिस्ट है. So see, I have explained all the plots in the last class. Okay, I'm going to upload that. I'm going to upload that video. I have not uploaded because it is the maybe I didn't get the time. So I will upload that video. Everybody should watch twice and thrice that video to understand the all plots. Okay, you understand all the plots and how we write all interpretation and everything that is given in the plot itself. We can just go through that. Okay? And second thing, once you have removed the point that is 72, okay, we need to again restore all the values. We have to restore all the values. So again, this is the storing the data. This is the storing the combined data. So again, we have store it. So we have stored the data. Now in this cell, I am storing in y2.1. Y, the variable is same. Now point 1 point means it is now we are changing the model. We are changing the model. Okay. So again, I will store same thing like that as we have stored it. Only dot one everywhere will be there. Okay. And here also I will put it 1 model 1.1. Okay. Model 1.1, and I'll execute everything. I will execute everything. I will run the model. I will run the model. I will check the all estimates of my model, whether that is significant or not. Whether that's significant or not. Okay. Because I have created a model and definitely I'm going to check that particular model is significant or not. So you can see, you can see here. First, you have to check for R square. R square कितना आ गया देखो अभी 68%. पहले कितना था 71% था. So if I remove that particular outlier in my data, my R square value will be properly, it is 68. Means actually my model is overfitted. My model is overfitted. Actually R square value ज़्यादा भी हुआ तो भी प्रॉब्लम होता है सिस्टम में. That is not there in this, that is your out of syllabus. Okay, it's called fit overfitted model. आपका जो मॉडल है वो ओवरफिट हो गया है बिकॉज ऑफ दैट पर्टिकुलर आउटलायर. तो जैसे मैंने इसको रिमूव किया तो आप देख सकते हो आपका जो आर स्क्वायर वैल्यू है वो प्रॉपरली हो गया 68%. बट स्टिल देयर इज आउटलायर और नॉट, यू हैव टू चेक इट. और फिर देखो यहाँ पे आप ओवरऑल मॉडल सिग्निफिकेंट है यस, तो फिर से इंडिविजुअल टेस्ट करना पड़ेगा. वो पूरा प्रोसीजर आपको फिर से वर्कआउट करना. ओके, तो कब तक करेंगे ये तो हमको भी मालूम नहीं, बिकॉज अगेन वी नीड टू ड्रॉ द प्लॉट एंड एवरीथिंग. तो फिर से प्लॉट करो, ड्रॉ प्लॉट करेंगे हम लोग. प्लॉट करके देखते हैं कुछ प्लॉट में आउटलायर आ रहा है क्या. आई विल सी नॉर्मल प्लॉट में आपको क्या है, अगर आप नॉर्मल प्लॉट देखोगे तो हमने डिस्कस किया था लास्ट क्लास में कि नॉर्मल प्लॉट केवल आपको डेटा बताएगा नॉर्मल है कि नहीं है. देयर मे बी सम पॉइंट, कैन सी देयर मे बी सम पॉइंट यू कैन सी हियर, बट almost all observations on the point. At some point it is, but which one we need to select, that is not showing by the QQ plot. Okay, यहाँ पे सब पॉइंट्स यहाँ पे है, मतलब आपका जो डेटा है वो नॉर्मल है, एब्सोल्युटली नॉर्मल है. बट यहाँ पे कुछ पॉइंट्स ऐसे हैं जो यहाँ वहाँ है, लेकिन कौन सा सिलेक्ट करना है दैट हाउ वी डिसाइड. तो वो नॉर्मल प्लॉट नहीं बताता. वो कौन बताता है, वो बताएगा आपको रेसिडुअल वर्सेस फिटेड प्लॉट. रेसिडुअल वर्सेस फिटेड प्लॉट बताएगा. Oh, I think I execute this. तो दिखा नहीं लास्ट में. अच्छा, I'll plot again. Yeah. So when you execute again, this is your plot. You can see, which is residual versus leverage. So based on, I told you, na, residual versus leverage, on the basis of that only you can able to get that whether there is an outlier in exist or not. You can see, so this is a cook distance point. Okay, So majority point is lying here, and these are the again corner points, and you can see 72 is outside the corner. 72, 77 is the outside of the corner. Even these points also outside. Even these points also outside. But 72 is a out of that corner. Okay, 77. Sorry, 77. So again we need to remove 77 from our data. Okay. So again we go to back in the model and we have to remove the 77. Can you see? So here now I'm writing point 2. Okay, point 2 because point 1 is over. So to point 2 कहाँ इन पॉइंट टू आई एम रिमूविंग 77, तो कहाँ से रिमूव करें 77 में से डॉट 1 में से, मतलब जो नया मॉडल हमने बनाया दिस इज दिस आई हैव स्टोर हियर राइट, तो वहाँ से मैंने वो डेटा सेट से मुझे 77 निकालना, तो फिर से मैं 77 निकाल दूंगा और फिर से मैं उसको स्टोर करूंगा नया वेरिएबल और फिर से मॉडल बनाऊंगा, और अभी मॉडल होगा मॉडल 1.2. ओके, and then I'll execute this model. Again I will check the summary of this. अच्छा object to is not right down one. तो फिर से summary आएगा, तो ध्यान से देखोगे अभी इस सिचुएशन में ध्यान से देखोगे तो आपका सब वेरिएबल सिग्निफिकेंस आ रहा है. देखो पहले बीटा 22 सिग्निफिकेंस नहीं आ रहा था, अभी बीटा 22 क्या आ गया, सिग्निफिकेंस आ गया. 3 स्टार मतलब सिग्निफिकेंस आ गया. देखो 3 स्टार मतलब कितना गया, 0.1 पे चेक कर रहा है. और आपका देखो ध्यान से देखोगे तो आपका आर स्क्वायर वैल्यू भी बढ़ गया है, मतलब मॉडल सिग्निफिकेंस हो गया है, मतलब आपका आर स्क्वायर वैल्यू सी द डिफरेंस, सी दैट पॉइंट का कितना वैल्यू होता है. आई हैव रिमूव द पॉइंट 77 and I found that because of that outlier, if you remove that outlier, how this r square value has increased by maybe some percent, and we found that our overall model is significant, even that each coefficient is also significant, is also less than 0.05. AB significant hai, AB significant hai, AB significant hai, right? Means you can stop here also, right? बट क्या करेंगे हम लोग एक बार वापस इसमें जाएंगे, प्लॉट में जाएंगे और चेक करेंगे कि अभी भी कुछ पॉइंट्स आ रहे हैं कि नहीं आ रहे. ओके. तो यहाँ पे मुझे क्या मिला कि सब जितने भी कोएफिशिएंट्स है सब सिग्निफिकेंट हो गए, राइट. तो सिग्निफिकेंट हो गए तो वी कैन स्टॉप हियर, नो प्रॉब्लम, इवन योर आर स्क्वायर वैल्यूज आल्सो हैज बीन इंक्रीज्ड. बट वी नीड टू चेक द प्लॉट्स, तो प्लॉट्स चेक करेंगे वापस से हम लोग एक बार. तो जैसे प्लॉट्स चेक करोगे आप, फिर से हम लोग लास्ट प्लॉट ही चेक करेंगे. I will zoom it. I will zoom it. I will share the screen. Can you able to see that plot?
Yes, sir.
So here we can see all the points. Maybe I told you that this point is near to the line. But it is not outside the line. You can consider this point is outlier, but this is not much affecting in my data. And और मुझे क्या मालूम पड़ गया, मेरा सब रिग्रेशन कोएफिशिएंट है वो सब सिग्निफिकेंस हो गया है ना, तो वी हैव टू स्टॉप देयर, डोंट गो बियॉन्ड ऑफ दैट. ओके, क्योंकि ओवरऑल मॉडल सिग्निफिकेंस हो गया, तो हम लोग इंडिविजुअल टेस्टिंग जाएंगे. इंडिविजुअल टेस्टिंग में सब कोएफिशिएंट मेरा सिग्निफिकेंस है, तो आगे कुछ टेस्ट करने की जरूरत ही नहीं है. मतलब दिस इज योर फाइनल स्टेप. You have to stop here and then we have to go for another testing जिसको बोलते हैं, तो MLR में आपको इतना करना है, MLR में आपको इतना सा वर्कआउट करना है. the screen for this. Then ये कौन सा ओपन हो गया? Okay, now so this is related to your this one residual of analysis. Okay, so residual analysis के हमने 3 प्लॉट किया है. तो डिटेक्शन पहले किया, अभी हम लोग हेट्रोसेडास्टिसिटी करेंगे. ओके, डिटेक्शन है, वो भी एक डिटेक्शन है. तो उसके लिए क्या करना है? उसके लिए आपको you have to install this package, install.package. install packages lm test करके होता है आपका linear model test के लिए, and have to install that. So once you install that, and now you apply this is called as Bush-Pagan test. BP test means Bush-Pagan test. Okay. So what this Bush-Pagan test does, it tell you whether the particular model, whether it is a heterogeneous model or homogeneous. So we have seen what is a heteroscedasticity, whether the variance is same or not. Okay, so we check using the BP test. Even that same thing can be done with another plot also, but I mentioned with the help of plot we can't clear about the concepts. Okay, so BP test is a clearly says which is Bush-Pagan test. That test we will study in the in unit 4, what is the meaning and how we can do the theory of that. Okay, let execute and see what it gives output. तो ये आपका ब्रूस पैगन टेस्ट का ये आता है, क्या बोलते हैं, आउटपुट. So can anyone tell me क्या इंटरप्रिटेशन होगा इसका ब्रूस पैगन टेस्ट का? कोई बता सकता है क्या उसका सिग्निफिकेंस होगा? The what will be the output? I have given the output, you have to interpret only.
We do not reject H naught.
Do not reject H naught. Okay, मतलब क्या? मतलब I may say that
Homoscedastic.
yes means my data is homogeneous. मेरा जो डेटा है होमोजीनियस है, लेकिन ये मॉडल मैंने कौन सा चेक किया है? मॉडल 1.2. मॉडल 1.2. अगर मैं मॉडल 1 यूज करूंगा या 1.1 करूंगा तो मेरा पी वैल्यू स्मॉलर आएगा, क्योंकि मॉडल उस समय मेरे मॉडल में मेरे आउटलायर था, मे बी एट दैट पॉइंट दैट इज नॉट सिग्निफिकेंट. ओके, ये सिचुएशन में इट इज होमोजीनियस है. ओके, तो क्या करना है आपको? अभी आपको जैसे मैंने सब डेटा कॉपी किया है वैसे ही आपको ये पार्ट कॉपी करना है. यहाँ से कॉपी करके आपके वर्ड में आना है, वर्ड में आके ये आपको पेस्ट इट. ओके, paste and you have to write down conclusion for this. So we have to define H naught. So what is your H naught? Data is homogeneous. Data, I can say variance is equal. Variance is equal versus H1 not H0. मतलब H0 मतलब क्या हो गया, it is homoscedasticity versus H1 heteroscedasticity, meaning is same. तो वेरिएंस इक्वल है कि नहीं है वो अपने को चेक करना है. तो वी फाउंड दैट p value equal to 0.6423 which is greater than alpha value which is 0.05. Therefore we do not reject H0, right? So this is for checking for heteroscedasticity using Bruch-Pagan test. Bruch-Pagan test. This is your second part, and we found that it is do not reject. Yeah, let me know if you have any query. No, I think no. Variance is equal versus variance is not equal. This is correct. You are do not rejecting, na? So do not rejecting matlab you are accepting the H. Yeah, correct. So whether you see, generally we write here in terms of parameter. H naught is not supposed to write like this. It can be statement always. We have studied, na? What is null hypothesis? Null hypothesis is the statement. We have to write in terms of either statement or we have to write whether in terms of parameter. So you can write sigma 1 is equal to sigma 2 is equal to sigma k like that, because I have not written because we have to write it down in the terms of mathematical. Okay, but that is okay, no problem. So heteroscedasticity को check करने के लिए have to use Bruch-Pagan test, and I have given the output for this. तो आप यहाँ पे syntax लिखेंगे हम लोग. Just write syntax. इसका syntax लिखिए आप. Okay, we'll write combined syntax. We'll write the combined syntax. And then we are approaching with the last one. What is the last one? Let me share again that. Okay, so Bruch-Pagan test is over. Now I have to check whether the assumption of normality is satisfied or not, and thus we apply the log transformation. तो log transformation हम लोग apply कर रहे हैं इधर. Log transformation in only dependent way. Only in the dependent way. So y2 is your new y2, which is log of y2 dot 2. y2 dot 2, and this is your new model 1.3, and based on that we have executed. Let's see whether it will run. तो मैंने log ट्रांसफॉर्म किया, मैं मॉडल चेक कर रहा हूँ, मॉडल 1.3 करूँगा और फिर से मेरा R2 कम हो गया. समरी लिया मैंने, फिर से प्लॉट करूँगा. फिर से प्लॉट करूँगा. डिस्टेंस में there are outlier exist. So if I did a transformation using log transformation, then check for PP test. Okay. So variability is there in the data. Shapiro test. So what we did actually here, uh, we found that the variance is same in our model, right? Variance is same in our model. So the data is homoscedasticity. That means there is no variability in the data. But we have found that the normality assumption, whether data is follow normal or not, okay, that was not satisfying using QQ plot. Using QQ plot. So we will use a log transformation. तो log transformation हम लोगों ने किया है और हमने ने मॉडल फिर से बनाया. मॉडल को फिर से चेक किया, समरी निकाला, फिर प्लॉट बनाया. प्लॉट बनाने के बाद फिर हम लोग मॉडल बनाने के बाद फिर से वेरिएबिलिटी तो आपको चेक करना पड़ेगा उसमें. तो हेट्रोस्कैडास्टिसिटी चेक किया हमने उसमें यूजिंग दिस टेस्ट. बट वी फाउंड दैट इस सिचुएशन में फिर से तुम्हारा दिस इज लेस देन 0.05 ना. सो वी आर रिजेक्टिंग, मतलब इधर ही हेट्रोस्कैडास्टिसिटी आ गया मॉडल में, वेरिएबिलिटी आ गया डेटा में. ओके, बट इफ यू चेक फॉर शैपिरो टेस्ट, क्या बोलता है देखो. शैपिरो टेस्ट क्या बोलता है, मतलब डेटा नॉर्मल है कि नहीं है. डेटा नॉर्मल है कि नहीं. शैपिरो टेस्ट क्या बोलता है, चेक फॉर नॉर्मलिटीज के लिए we need to check whether your data is normal or not. So whether data is normal or not, we can always check by Shapiro test. So Shapiro test, I will just paste this output in my uh, Word file. Then let me know whether so you can see this again here. So what is your H naught here? H naught means data is normally distributed. Normally distributed versus H1 not H. So if I'm saying data is normally distributed, so what is your conclusion? P value is equal to coming 4 point in this value. And I know that this value is lesser than 0.05. That means we reject H naught. Reject H naught means what? Data is not normally distributed. Data is not normally distributed, and we can stop here. We can we can stop here. तो इतना सब कुछ करना है अपने को एक प्रॉब्लम है. This is all we have to do it in remaining all the problems. So कहाँ stop करना है, कैसे stop करना है? So if anyone can tell me. But we need to perform all. तो जो हमने किया यहाँ पे. So I'll just take the recap. You have to go on this, perform your summary of model. बनाने के बाद आपको output जो आता है यहाँ पे लिखना है. Using that plot, that is your residual versus leverage point, में चेक करना है कब तक वो पॉइंट्स आपका कंटिन्यू आ रहा है. उसको रिमूव करना है. रिमूव करने के बाद जो मॉडल मिलेगा दैट इज योर सिग्निफिकेंस. So to do twice, thrice. Okay, you have to do twice, thrice, and then based on that, once there is no outlier exist, you have to stop there, and you have to go for next one, which is called heteroscedasticity. Heteroscedasticity आपको परफॉर्म करना है और वेरिएंस सेम नहीं आता है. थर्ड वन, यू नीड टू चेक नॉर्मेलिटी. तो नॉर्मेलिटी चेक करने के लिए we have to transform the model. We have to transform the model, which you have to take log. तो एक बार log ट्रांसफॉर्मेशन ले लेते हो, और log ट्रांसफॉर्मेशन केवल आपको डिपेंडेंट वेरिएबल का लेना है, याद रखो. डेटा नॉर्मल है कि नहीं वो चेक करना है आपको. तो अपने को क्या बोलते हैं, you need to check for, see this is, I don't know why they have given everything